Hey guys, so this video is going to be looking at RStudio with chi-squared and just reminding you of a few important things to keep in mind and be aware of. So I'm going to go do that real quick, and so I'm going to pause you and then go to RStudio real quick. Alright, so right now I have the pre-lab open. So a couple of things that they have you do to begin with is they have you make a table and name it something. So the table feature is how we do chi-square tests in RStudio. So you have to make a table, but it really is helpful for you to name the table. So I'm just going to give you an example. This is the example we did in class using the Karloff dataset. So let's say I want to make a table for the class variable. So I'm going to name it class. I'm going to say table, Karloff, class. And do that. So just running that code, if I name it something, it's not going to show up. It shows up over here, but it doesn't. So if I want to see it, I just would type class and run that. And there's my table. I have 28 freshmen, 22 juniors, 28 seniors, and 22 sophomores. So if I wanted to do a chi-square test to see if the proportions of each class are equally distributed, what I have to do for a chi-squared goodness of fit test is I have to define the expected variables. So I'm going to name that expected class, and then I'm basically just giving it the proportions that I expect. So if my null hypothesis, if my claim is that they're equally distributed, or if the question is saying, do we have evidence that they are or are not equally distributed, that means I expect there to be an equal amount in each group. So for proportions, I'm going to type C parentheses, I'm going to say 0.25, 0.25, 0.25, 0.25. So that's my null hypothesis, or the claim that they're equally distributed. I have 4 groups, so to make that equally distributed, I need 25% in each group. So I would do that. So I have to give it that expected class thing. You'll kind of notice that in the pre-lab, we set up this expect gender, and that is the 50%, 50%. So I have to set that up. So when I go to run the test, my test is chi-sq.test. Excuse me, I'm going to give it the table name, which was class, and then I also am going to give it the expected values by saying p equals, and then the name of that vector that we created with the expected values. So I say the name of the table, and then p equals, and then the name of that expected variable that you set up. The other thing you could do, let me run that. So then we run the test. It gives us down here our chi-squared value, it gives us our degrees of freedom, and it gives us our p-value. Remember, in RStudio, we're always using p-value to make that determination of to reject or fail to reject the null. If your p-value is really big, if it's bigger than 0.05, we fail to reject. If your p-value is smaller than 0.05, we reject the null. The little rule I gave you was if p is small, reject the null. Kind of rhymes. P is low, reject the hoe was the more rhymey way. One thing I wanted to mention, I said this thing about when you create the table you have to name it. You technically don't. I could type in chi-square test. I could say table Karloff class, right? I could just type the table code within there and it would still work just fine. It just makes it a little bit easier on yourself if you name it first. If I try to just say chi-square test table, or with Karloff class, it's not going to work. It's going to be like, I don't know what that is. So it needs a table. You can either do that by typing the entire table code in there, but you could also have created the table earlier and named it, and then just type the name of the table, and that would work. So I wanted to point that out. So that is for our chi-squared goodness of fit. Again, the expected part is important. So let's say the question was like, we expect there to be a whole lot of freshmen. So maybe they set this up earlier in the test or problem. They said, we expect 75% freshmen, 10% on the next one, 85, 90, and 0.7. So if they give you a different set of expected proportions, that's what I would type into that C parentheses, just whatever that expected proportions is. And then when I run the test, it's telling me if it's different from that. So your expected little vector here is important, and you're getting that from the problem, from the data that they give you, or the problem itself. They'll tell you what the claim is or what you expect. So that is chi-squared goodness of fits, and I'm going to talk just a minute about chi-squared test of independence, which is for two variables. So if I look back at my pre-lab, you'll notice, so for question 2, we were looking at, is there an association between gender and how many weeks they're on the top 10. So again, they first created a table and named it. So for example, if I wanted to find out, is there an association between gender and what are the variables? I'm going to make one up real quick. Maybe between gender or sex and whether they're diagnosed with lycanthropy or Wendigo-speed. Let's do that. Let's do diagnosis. So I just called my table because I'm lazy right now. So I'm going to say Karloff class, comma, Karloff diagnosis. Why did I say class? What did I say? Sex? Okay. So I have this table. Again, if I want to see the table right now, I can. There it is. So that tells me how many females and males they have in lycanthropy and Wendigo-speed. So then if I want to test for a chi-square test, I'm going to do the same chi-square test. I'm going to give it the name of the table. And then I have to do one thing for a test of independence. I have to say this thing of correct equals false. Why? I don't know, but that's what we have to type. Seems weird, but there you go. And then I'm going to run it. It's going to give me the test. And then, yeah, we just use that to run our table. Again, if you named the table, you would write the name of the table right here. If I named the table gender diagnosis something, then that's what I would put right here. So if I ran that and that was the name of the table, I would just put the name of the table right here. Right? But I could also just type table parentheses Karloff. So I could type the whole code for that thing in there, and that would work the same way. It just takes a little bit more effort. So that is what I wanted to tell you about that. And then the last thing, and this works for either test, so the chi-square goodness of fit or the test of independence. The other thing you might need to know at some point in time is you might need to know the, I'm going to change this back to just say table, because that's easier. You might need to know at some point the expected, what are the expected values? So like, let's say that was my proportions that I expected for that test, and I could go ahead and run the test, and there's all the information, but if I wanted to know what are those expected values, what I can do, so I'm just going to copy that code, is at the end of this, before I push, or run that code, if I push $expected, it'll tell me, that'll give me a table that tells me all the expected values based on your proportions up here. And same thing down here. If I wanted to know for this test of independence, what are the expected values, I would just add a $expected at the end of that code, and then it gives me a table that has the expected values. And that's really helpful to know. One thing I wanted to mention that I didn't mention in the other two lesson videos, for a chi-squared test to work, for us to trust the results we get from it, one of the conditions is that our expected counts are all greater than 5. Not something I mentioned. It's in the textbook, but it's a good thing to know. So sometimes if your expected counts were smaller than that, it would give you an error. It's still going to run the test. So for example, let me change some of these around. Make some of these really small. So if I said that, oops, oh my goodness, I'm trying to make the expected counts really small. So when I run this test, notice that it gives me this warning message where it says the approximation may be incorrect. It still ran the test. It just gave me this warning that's telling me your expected counts were really low, so this chi-square test may not be super accurate. It may not be giving you good information. You can still run it, it's just our results are a little dubious because the expected counts were so small. So that is a rule for chi-squared. Our expected counts need to be at least 5 or bigger in order for us to trust the results we get from that test, in order for them to be like accurate or representative. So that is a good thing to know. Anyways, I'm done for now. That is all of the videos for this unit. Hope you guys are doing well. Have a good day.